Assalamualaikum warahmatullahi wabarakatuh. Good evening. Today, I want to share to you about Bourdon tube pressure gauge open-ended experiment. Our group member consists of Navin Raj, Arif Imran, and me, Muhammad Fazli Fitri. So, I want to explain more about the abstract of this experiment. In the calibration of Bourdon gauge pressure, we are necessary to compare the experimental result with an actual result. We also need to detect the error in order to calibrate the pressure of the gauge. To calibrate a measurement system, we must use a various type of pressure measurement instrument to compare its output with a standard established input. The Bourdon tube pressure gauge is one of these equipment. The Bourdon gauge, named after its inventor Eugene Bourdon, used the reflection of an oval cross-section tube to pass a pointer over a scale. This system may be calibrated by mounting the transducer in a closed vessel at one end with a piston.
Good evening. Now I'm going to explain about the objective. Our main objective will be compare the force exerted by the fluid jet impinging upon a flat or semi-spherical surface with a theoretical value. Next will be the apparatus. We have deflector, nozzle, main switch box, flow control valve, volumetric measuring tank, sliding valve, water drain, water supply, tank, and lever mechanism. We can see the positioning of the apparatus here. Next will be theory. A jet of fluid when impinging upon a flat plate or semi-spherical surface generates a force due to change of momentum of the fluid according to the Newton's second law of motion. For example, when a velocity of water from jet nozzle with diameter strikes on a flat plate or semi-spherical surface, the rate change of the momentum produced and its magnitude is same with the force exerted on the surface of the flat plate or semi-spherical to support the water jet. The F generated, which is the force generated, may a jet of water when it strikes depends on the shape of the surface, flat or semi-spherical. Figure 1 and 2 shows a jet of fluid issued from a nozzle of diameter moving vertically upward with a velocity v1 and strikes a flat plate and semi-spherical surface respectively. The jet is deflected by the surface of the flat or semi-spherical through an angle and leaves the surface with v2. Basically, like if it's a flat surface, it will be like this, and it's obviously if the water strikes this way, it's either will go to the left hand side or the right hand side. It won't be going downwards because the water is flowing upwards, and if it is bent, then automatically it will go the other way around because it is bent. Technically, it won't have the space to go to the right or to the left. The theoretical force generated when a jet of fluid strikes a flat surface, we have the equation F equal to density times area times square of the volume. So square of the velocity. We have two velocities basically before hitting and after hitting. Since it's 90 degree, V2 will be 0, cos 90 is 0. So for flat surface, we have F is equal to rho A V square of the initial velocity, which is V1. For semi-spherical, we have F equal to 2 rho A V square of the initial one. That's all from me. Thank you.
So now I'm going to talk about the methodology. So the apparatus needed is a Bourdon tube pressure gauge, piston 1 kilogram and dead weight tester 0.5 kilogram 10. The procedure is the piston was inserted into the cylinder. Second, no air bubble were ensured in the tube. The third one is the first reading was taken. The fourth one is 0.5 kilogram weight were added to the piston. Fifth, the reading of Bourdon pressure gauge was taken. Step 4 and step 5 were repeated for all different weight. Seventh, after the total of 5 kilogram weight has been removed one by one and the reading was taken. Eighth, this experiment was repeated and the average reading was taken. Ninth, the reading were recorded. Result and discussion. This is the table of the result. And now the discussion. The mass, this is the calculation for mass 1 kilogram and the area of piston is 317.13 millimeter squared. We must convert it to meter squared to get to the formula, to follow the formula. So the formula is actual pressure PTH is equal to force exerted by the piston over the cross section area of piston, and we get 30.9 kilopascal. Second, actual pressure exerted when mass increased by 0.5 kilogram, and we got 46.4 kilopascal. Now the calculation of percentage error. For loading, percentage error, gate pressure minus actual pressure over actual pressure times 100. And for the calculation we get 35.3%. For unloading, the percentage error we get is also 35.3%. So now this is the table for all the calculation. From the table above, we can see that the pressure F and actual theoretical pressure cause a huge differences when the weight increase, and that's the reason why the percentage of relative error for the theoretical and measured pressure gauge is big. This error happen maybe because have slight error when doing the experiment. Same goes to the percentage error between true pressure and the calibrated pressure for decreasing order of weight. Even though some readings are not consistent, less error was made for this experiment. The source of error and method to minimize the error. The first error is parallax error when positioning of the eye when measuring the scale in Bourdon gauge. Second, the presence of air bubble in the cylinder. And the third one is some faulty measuring instrument and incorrect calibration of the scale reading, especially on the Bourdon gauge. How to minimize it? We minimize it by making sure that the eye level is perpendicular to the scale that needs to be read when taking the reading. Next, by putting a moderate amount of oil into the cylinder to prevent air bubbles from building up inside the cylinder. And this piston have to be rotated to remove air bubbles in the hose in order to reduce the friction in piston. Repeatability and accuracy of this experiment. As we know, the apparatus is very sensitive to shock and vibration. This can cause slight different result when we do the experiment. So that's why we repeat the experiment 3 times to get the average result that can satisfy our reading. Larger division scale on the equipment also affects the accuracy of pressure reading. So the way we prevent this by using more sensitive equipment to obtain an accurate pressure reading. When we add weight, the dead weight pressure calibrate the response slowly to the gauge in pressure and the friction. So we rotate the piston to remove air bubble inside the cylinder tube and to reduce friction to obtain more accurate reading pressure.
So for the conclusion, we basically based on this experiment, we can infer that a Bourdon gauge is one of the required pressure measurement instrument. This is because according to the theoretical value, the Bourdon gauge gives around 90% accuracy in reading the pressure. We cannot prove that 100% correct, but we can also minimize the inaccuracy of the reading by repeating the experiment to get the average value. So that's all from us. Thank you.